Hey guys, Mr. Murphy here with another video lesson for you. This one is on what we're going to call interior angles of circles. So interior angles of circles are angles that look like the one with this question mark right here. Now where's the vertex of this angle? The vertex is right here at letter J. Now, if you notice, this vertex is inside the circle, hence interior. But it's not at the center of the circle. The center of the circle would probably be somewhere around here, right? So for interior angles, think of them as angles in circles where the vertex is in the circle, but not at the center. So in the circle, but not at the center. Okay. Now, just like with central angles, where the vertex is at the center, or inscribed angles, where the vertex is right here on the circle, there are rules for finding the measure of these angles, these interior angles, using arcs that we have on the circle. And the rule for interior angles goes like this. Interior angle is equal to 1/2, let's say A plus B. Now, when I say A plus B represents the measures of these intercepted arcs. So one of the intercepted arcs would be right here, and then the other intercepted arc would actually be on the opposite side of that, so arc MB in this case. Okay. Now, we're used to using the arc across from our angle, but why am I using the arc kind of behind the angle, so to speak? Well, the reason for that is this angle, even though I don't know its measure yet, has the same measure as that angle, right? Now, obviously, these arcs are different sizes, but these two angles are the same. Therefore, what I'm trying to do is really average the two arcs. So let's call this one A, this one B, and we'll go ahead and find out the measure of our angle. So I'm going to do angle equals 1/2, and then A would be the 50 degrees, plus B would be the 156. Bring down the 1/2. Then I'm going to add inside the parentheses, 50 plus 156 should give me 206 degrees. And then I just take half of that. When I take half of something, remember you're dividing by 2. So 1/2 times 206, or 206 divided by 2, should give you an angle measure of 103 degrees. Cool. All right. So this is the main relationship for interior angles of circles, aka angles where vertex is inside the circle but not at the center. The relationship you want to use is this. Angle equals 1/2 of A plus B. A plus B being the two intercepted arcs. One opposite, and then one on the other side. Cool. Alright. Number 2, we can see we're dealing with the same types of angles. I have this 69-degree angle right here at CBD. And what we're trying to find in this case is the measure of arc CD. So this time we know the angle and we want to find the measure of one of our arcs. So we're going to do that. Now I have this other arc over here that can help me, just like before. Remember, we want those two intercepted arcs. Again, I'm going to label my arcs as, let's do it, A and B. And then my angle is 69 degrees. So when I set this up right away, the number I can plug in place of the angle is 69 degrees. On the other side, I know that the relationship we learned, the little formula, has a 1/2 in it, so I'm going to go ahead and write that. And then when I do A plus B, A is the measure of the arc we don't know, so I'm going to keep that as a letter, as a variable. Then B, I'm going to substitute the other arc, so A plus B. In this case, that would be A plus 53 degrees. All right. Now, since I'm solving for A instead of the angle, I have to do my math in a little bit of a different order. I look at the parentheses over here, and since a is a variable, I can't add. But what I can do is try to get rid of this 1/2. Now, remember how we said 1/2 is really kind of dividing by 2? Well, what would be the opposite of that? It would be to multiply by 2. So I'm going to take both sides, multiply by 2. That's going to be my first step. Both sides multiply by 2. What happens on the right is that this 2 cancels out this 1/2, leaving me with a plus 53, and I can drop the parentheses. Over here, I just have to multiply 2 times 69. 2 times 60 is 120, 2 times 9 is 18, so that's going to be 138 altogether. And then here we go. I have 138 equals a plus 53. Now, subtract your 53, and that leaves me with a by itself. 138 minus 53 is going to give me 85 degrees, which I can write out here because now I know that's the measure of my arc. Cool. All right. So we were able to find measures of angles and measures of arcs using this new interior angle relationship. Now, I'm going to give you just kind of a little phrase to help you remember that relationship by. It's going to be interior angle equals half the sum of the arcs. The interior angle equals half the sum of the arcs. That is a way that you can remember this formula. The interior angle equals 1/2 a plus b. A plus b represents sum of the arcs. Half, of course, represents the 1/2, and then just set that equal to your angle. Okay, cool. Now, I want to do one more with you, which brings in some variables into the mix. So, if we want to solve for x, which we see over here, we can use the same interior angle property we've just been practicing. So, this 28x minus 2 represents the measure of arc ED. I have another arc over here, FR, that has a measure of 86 degrees. And then I have my angle over here, which is 98 degrees. Now, I know that the angle is going to be equal to 1/2 of a plus b. So I'm going to go ahead and label this arc A, this arc B. My angle is 98 degrees. Keep the 1/2. And then when I plug in A, I'm going to plug in all of this. 28x minus 2 plus B, which is 86 degrees. Okay. And I put this in parentheses just to show that's the measure of a single arc. But later on, when we do stuff involving subtraction, it may be important to keep those parentheses. But I technically don't need them in this case. I could also write it like this. 28x minus 2 plus 86. Okay. Cool. All right, now I'm going to go ahead and inside my parentheses combine my like terms. I don't have any x's other than the 28x, so I'm not going to change that. That's going to stay 28x. Bring down everything else while I'm at it. But this minus 2 plus 86, I can combine. That combines to give you, that's a minus 2, so that's going to become a plus 84. Okay? All right. Now, I could distribute this 1/2 to both of these numbers, or I could do what we did over here and cancel out the 1/2 by multiplying both sides by 2. Personally, I find this a little bit easier than multiplying in a fraction, but it's really up to you. I'm going to show that, though. So on both sides, I'm going to multiply by 2. That cancels this out, leaving me with 28x plus 84 on the right. On the left, 2 times 98. 2 times 90 is 180. 2 times 8 is 16. So that's 196 after multiplying by 2. Subtract your 84 from both sides. That leaves me with 28x equals 6 minus 4 gives me 2, 19 minus 8 gives me 11, so 112. And last but not least, divide by 28. Alright, let me move this up. That cancels out this 28. And then how many times does 28 go into 112? The correct answer would be 4. X is going to be equal to 4. And that is how you can use interior angles and their relationship with the arcs to set up and solve equations like this one. I just take this angle equals 1/2 a plus b. In other words, interior angle equals half the sum of arcs, and plug in the information that I have, whether it's angle, arc, whatever. Okay? Just make sure the arcs you're looking for, notice I've highlighted them in color. If that's the angle I want, these are the 2 arcs I need. And just like over here, if this is the angle I have, then these are the 2 arcs I can find out about. Okay, that's going to be it for this video. I will include these problems on the comments section of the video in case you want to try them out and follow along. Alright, have a great day, guys.